Our code begins with importing some of the data. We are feeding the data into our model from our drive. We have mounted a drive here. Similarly, we are importing some of the libraries which will be required for our code. The dataset has been loaded and we are doing some part of pre-processing with it. Now, we will be defining some of the models after the pre-processing. Once we are done with pre-processing, we have defined our 6 machine learning models. The 6 machine learning models once defined and executed so that we could know the results behind them are then passed into serial and parallel functions. It takes some time for our models to get defined and then we run them serially. We are at each step taking this time into consideration taken by our program. Similarly, we are plotting our graph so that we could know the results which we are getting in the backend. And this has been done to make sure that the serial and parallel are giving us nearly same results, because if parallel gives us some discrepancy in results, it won't be useful for us. The backends are low-key, multiprocessing, threading, which will be run one by one. And once they are done with running, we will be plotting the graph for the time taken by each of them. As soon as the execution completes, we plot the respective timings, and we can see that Loki takes the minimum time of the four above. Taking the previous results achieved from above execution, we process them a bit so that we could feed them in our prediction functions. The first function defined here is our PyMP. So let's install the PyMP and then we could import the same. Once we import PyMP, we will be using PyMP so that we could parallelize our loop. This is defining simple average without any parallelism. And the final results which we will be expecting would be like don't buy and buy. Similarly defining parallel and parallelizing it with PyMP library. The same goes for weighted average using parallel, exponential average using parallel. Once we have defined all our functions, we are passing these functions serially and parallelly. So this is the first serial pass which gives us the least time. Once we get the results for serial passing of them, we see that linear is taking the least time. Here, we have tried to use low-key multiprocessing and threading all of the three as our backends. Then, what happens if we extend our data? When we extend our data, the results are further skewed to better graphs. Loki does take more time, but linear and threading are near to them. So let's try and do that. Once done, the results are like this. But this is not what we want from HPC. So we go for the parallel functions. Once we jump to parallel function, we see that the graphs have come near. Though linear is taking the least time, but there seems a hope that if we go for extended data, the results could be in our favor. So what we do further is go for extended data. And as soon as we run our model for the extended data, the results are in our favor. And you can clearly see that Loki is taking the least time, linear is taking far more time, and multiprocessing in between. Thus, we can say that with parallelly implemented internal functions, we can make the most optimized solution using Loki backend. So that was all about our code and its parallel implementation. Thank you and thanks for watching.